Hi everyone, I am Madam Rosmaya. In this video, we are going to discuss on checkpoint 21.2 part 1 because we are going to discuss only two questions from this checkpoint. Okay, the first question. A wire is stretched between two fixed points 0.50 meter apart. So A, what is the frequency of the sound emitted when the wire vibrates in the fundamental mode? B, describe the change in the frequency of the sound emitted when the tension in the wire is increased. The wire is substituted with the thicker wire of the same material. The tension in both the wires are the same. Given that speed of sound in air is 330 meter per second. So for first question, a stretched wire between two fixed points for distance 0.50 meter. So the shape for the fundamental mode is like this, where we have two nodes and one antinode. So from V equals to F lambda and F equals to V per lambda, so we are going to substitute the speed 330 meter per second. For the lambda, we can determine by the shape of the wave here for fundamental mode. So it's equals to the length 0.50. So the shape is half lambda. So half lambda equals to L. So cross multiply, we get lambda equals to 1.00 meter. Okay, now F equals to 330 divided by 1 meter. So frequency is 330 Hz for question 1A. This frequency is for the frequency of the fundamental mode. Okay, next question. Describe the change in the frequency of the sound emitted when the tension in the wire is increased. So from the equation V equals to square root of T per mu, where V is the speed of the wave and T is tension in the string and mu is the mass per unit length. So from the equations, the speed of the wave is directly proportional to the square root of tension in the string. And the V is equals to F lambda, so V is directly proportional to the frequency. So therefore, frequency also directly proportional to the square root of tension. So that's mean when the T increases, frequency also increases. Okay, next we are going to discuss B2. The wire is substituted with a thicker wire of the same material. The tension of the wires are the same. So from the same equation, V equals to square root of T per mu. V is directly V is inversely proportional to square root of mu. So V is directly proportional to F. So therefore F also inversely proportional to square root of mu. So thicker wire means larger mass, or means that M increases. So when M increases, frequency decreases because of inversely proportional to square root of mu. So that's the answer for B2. Okay, next we are going to discuss question 2. Sound is produced by a stretched string. The frequency of the second harmonic is 165 Hz. So calculate the length of the string and the frequency of the second overtone. The speed of sound in the air is 330 meter per second. So first question. This is the first harmonic where we discussed in the previous slide. So second harmonics means the shape of the wave is two loops here, form two loops. And we are going to determine the length of the string. So the length of the string is equals to lambda. From the shape of the wave here form, we have three nodes and two antinodes. So that's mean the shape of the wave is equals to the lambda and equals to the length of the string. Okay, we are going to find the lambda from v equals to f lambda. Lambda equals to v per f. So we substitute the v 330 meter per second and frequency 165 hertz. So we get lambda equals to 2.00 meter. So therefore, the length of the string is 2.00 meter. Okay, so done for the 1A. Next, 1B. So for 1B, we are going to find the frequency of the second overtone. So second overtones means 3 loops here. So second overtones means third harmonic. For second harmonic is first overtone. Third harmonic is second overtone. Okay, so from the loops form here, and v equals to f lambda, f equals to v per lambda. So the loop here we have 1, 2, 3, 4 antinodes and 1, 2, 3, 3 nodes. So that means the shape of the wave is 1.5 lambda. So 1.5 lambda is equals to 3 per 2 lambda, and this is equals to the length of the string. So therefore, we substitute the length that we have calculated in 1A, which is 2 meter, equals to 3 per 2 lambda. So cross multiply, we get lambda equals to 4 per 3 meter. So now we substitute the values into here. V is 332 meter per second and lambda is 4 per 3 meter. So frequency is 248 Hz, 248 Hz. So that's the answer for question 1B. Okay, so that's all for the discussion on the checkpoint 21.2. So hope that you all can understand. Thank you for watching.